The green premium is a big challenge faced
Yes.
by a lot of climate tech companies around the world.
When we get mass market adoption is, I think, when a little more of the regulations come in, and then maybe there's more of a customer driven demand behind it.
We see so many different types and variations of green concrete, approaching it from different angles. You've got your calcination, you've got your alternate concrete recipes.
That's another really big issue is MRV, measurement, reporting, and verification.
Tim, hey, thanks so much for joining me today.
Pleasure to be here. Thanks for having me on.
So why don't we get started by you introducing yourself and talking about some of the work that you do at Carbon Limit?
Sure. Great to be here. It's Tim Sperry, Carbon Limit, founder and CEO. And with Carbon Limit, we're creating sustainable technologies for the built environment, specifically concrete.
Amazing. And the world of low carbon, sort of green concrete is a pretty hot space at the minute. And it's a topic that's come up a few times on our podcast already over the last sort of year or so. I'm always interested in what encourages people to go into the world of concrete. It's not the sexiest of sectors. I mean, what was your sort of pull to getting involved in concrete?
Yeah, actually, my background has nothing to do with concrete. So my background is in more carbon capture technology. I'm a scientist and an entrepreneur, so I love to invent things and then I love to sell them. When we started Carbon Limit, it was always meant to be a carbon capture sustainable solution company. We created a big shipping container that captured CO2 directly from the air, scrubbed the CO2, and then what was meant to go with that material that was saturated with CO2 is we meant to put it into roads, bridges, buildings. So it effectively was meant to go into concrete. Concrete's the second most used material on this planet. So what better way to store CO2 into something that is everywhere and actually could be a permanent solution? So ended up just coming into it because we saw it as a storage solution for CO2 and for our technology. But then we ended up pivoting. That turned us into a partial cement replacement that lowered the carbon footprint because cement is the biggest carbon footprint of concrete, and then capturing and absorbing CO2 into the concrete, further capturing and storing more CO2 directly from the air. So again, just ended up being a good vehicle for our solution.
I want to dive into the work that you do because I've learned all about your solution and it's quite a fascinating product that you've described and the work that you do at Carbon Limit, because you've essentially produced this material which can go into roads, into our infrastructure schemes, but can absorb carbon. So would you mind just talking us through how it is that you've been able to produce this material that does that?
Absolutely. So yeah, we've created Crete is the name of our technology. It's the world's first CO2 capturing concrete technology. So what we did was we took active minerals that have reactivity to CO2 from the air, and we made it into a part of the concrete that could be made and mixed into a road, a bridge, or a building. What happens is we put this active material in there, we mix the concrete, it's made into the concrete product, and it gives that concrete and transforms it into an actual active carbon capture and storage solution. So think of a big magnetic sponge where it's actually pulling CO2 directly from out of the air, and then it mineralizes the CO2. So actually turns the CO2 molecule into a solid mineral in the concrete, and it's actually stored permanently. Unless you incinerate the road or the concrete product itself, which we're not really incinerating much concrete. So just trying to create an easy solution for CO2 pollution.
What are the minerals that you use to be able to do this? I'm fascinated by it.
Yeah, so to get somewhat scientific, these are inorganic mafic minerals. They're class N pozzolans. What does that mean? These are special minerals that have big surface area, big adsorption surface area, that also have pozzolanic properties, which are the same properties that cement has in your concrete. Cement is the glue that holds it together. So this kind of has that glue property that cement does. And these actually have a affinity for CO2 molecules, actually gives it to be able to absorb them in and around the surface. As the CO2 is absorbed into these materials, it actually reacts with the other materials in concrete, the cement and capturecrete, and it chemically reacts with those CO2 molecules to turn into a calcium carbonate, which is like a fine white powder. It's a solid mineral. So these are minerals that are found all over the Earth's crust range from different materials, from like volcanic material to other natural minerals that just have these special properties. And our special sauce on top of that is a metal oxide catalyst. That's something that accelerates the carbonation process. What most people don't know, and some people do know, is concrete actually is a carbon sink. It actually does capture some CO2, albeit very inefficiently and very passively. Our technology just creates a very active process of doing that, enhancing its natural ability and increasing its ability to capture and absorb and store CO2.
How much CO2 can it absorb? How would it compare to obviously one of the big pushes in the built environment at the minute is carbon capture. So point source capture as well as then direct air capture.
That's right.
And then you have other forms of carbon capture out there. But how does this approach compare to those other solutions that we see in the marketplace?
So this doesn't require a big piece of equipment. This doesn't require actually capturing the CO2 into a sorbent, desorbing it, turning it into a liquid CO2 in a supercritical state, compressing it, putting it into a canister, and then shipping it away and actually adding transport. This effectively gives an active mineral the ability to capture it from the air, which is called carbon mineralization. Kind of a related one would be enhanced rock weathering, where the materials react with your precipitation, the air itself, and the actual properties of the minerals. And we've combined those, so it actually does function similarly to that. And the direct air capture piece would be the act of absorbing into the actual concrete and into the material with this capturecrete in it. So how much does it capture? It depends. It's really hard to quantify and for people to understand how much a kilogram of CO2 is, a ton of CO2 is. But what we find is that when we're capturing CO2 into the concrete, we can see extra kilograms up to 10, 20, 30, 40 kilograms of CO2 additional into a cubic meter of concrete or to a metric ton. So there is a significant amount. I mean, it's hard to understand an invisible material in the air that turns into a solid mineral, changing the volume and the densities. But it actually does have a significant ability. If you were to look at trees could capture maybe 20 to 40 kilograms of CO2. So maybe every cubic meter or every metric ton of concrete could capture as much CO2, extra CO2 as a tree does or a couple of trees. Maybe that's an easier way for everyone to understand. So we're effectively paving roads, which are like putting up forests.
I love it. It's and everyone loves a tree measurement, right?
Yeah.
How many trees is it equivalent to?
Yeah, exactly.
real scientific measurement there.
Scientific.
Yeah. I mean, because obviously the challenge with the world of direct air capture at the minute is how energy intensive it can be. And there are so many different bets that I guess venture capital funds have made in terms of which type of direct air capture solution is going to be the right one. Is it going to be the one that sort of self generates its own energy, or it plugs into an existing industrial power unit to then sort of use via the heat offsets?
Yep.
There are loads of different sort of approaches and attempts at trying to overcome this inevitable need for energy. So actually, the fact that you are not only able to capture CO2 at scale, almost passively, without any form of power, but also allow the infrastructure sector to continue to scale and build these roads and other forms of critical assets. So it's a bit of a win-win.
Yeah, and look, that's exactly what we look to do with this business model was how can we make it as affordable as possible, as adoptable as possible, and as scalable as possible? And when you look at a direct air capture machine, carbon removals are needed. There's just no question now. We need to remove carbon. And most people, when they think of removing carbon, they think of a giant box that's sucking air down into it and it's removing some of the CO2. Even more so, there's a huge carbon footprint associated just with building these big facilities and the manpower to get there and people going to work and measurements and reportings and verifications. And there's constant measurement requirements too. That's another really big issue is MRV, measurement, reporting, and verification of those carbon credits. Well, when you're capturing CO2 from the air, then you compress it and then you put it into a canister or you store it underground in a class 6 well. How do you that CO2 molecule is actually being stored? You have to measure it. You have to verify it. You have to monitor it. And that costs money, that takes time, and that creates carbon footprint by itself as well. So this solution is no additional equipment for your concrete producers to add capturecrete to their concrete. And then once it's capturing the CO2 from the air, which doesn't require any energy either, that CO2 is in solid form. It's thermodynamically and kinetically stable, meaning it won't release itself back into the atmosphere.
I guess sort of stepping back from that slightly and thinking about the world of green concrete and sort of low carbon concrete, we see so many different types, similar to direct air capture. We see so many different types and variations of green concrete, approaching it from different angles. You've got your sort of your calcination, you've got your alternate concrete recipes, you've got your additives, your supplementary
Mm-hmm.
cementatious materials. It varies considerably, right?
Yep.
I'd love to just pick your brain around what that market looks like and the different types or the different attempts at trying to produce green concrete and the part of that market that your work at Carbon Limit slots into.
Yeah, absolutely. People ask this all the time. What does that competitive landscape looks like? And I always like to say, for us, it's a collaborative landscape because all of the different ways that we're talking about, and I'll mention, these are solutions that are lowering the carbon footprint of concrete, storing CO2 into concrete, whether it's injecting CO2 or another format that makes it more sustainable and more green. Well, the best part is we see ourselves as being able to stack on top of these solutions. So even our competitor could be our best friend, and we could be partners in this way to make their concrete even more sustainable and create a bigger impact together, right? So in our market here, which we're based in the US, so there's a little bit of a difference between our markets with different specifications that are needed, but also with different avenues that are being approached. I think some of the similar ways are very easy, which is like slag or fly ash, which is a post-industrial waste that's from coal or from steel or from ground blast furnace slag. And those solutions help reduce the amount of cement. Cement, again, is the biggest carbon footprint there. So you're effectively using a waste to lower the carbon footprint. It works great. There's other things, there's natural pozzolans, which are actually kind of part of our material too, specific type of natural pozzolans as well. We're using something that just has a lower carbon footprint. There's other ways where you do carbon curing, where you're taking a CO2 chamber with concrete blocks or concrete products in there, and you're actually putting CO2 in there to absorb the CO2 into that, or CO2 injection, where you're taking point source captured CO2 and injecting that into the concrete while it's being manufactured to help create better performance, minimize the amount of CO2, and then effectively storing carbon in there while you're reducing some of the carbon footprint from some of the savings of the cement. So again, all of these different solutions are effectively solutions we can be a collaboration with by adding capturecrete to those. I really see there's a huge need to reduce carbon footprint, lower carbon footprint, and I don't think there's one silver bullet right now. I think eventually what we'll see, Jack, is that there's going to be maybe a handful of top selections that will come out because there's so many solutions right now. We couldn't even get through all of them in this podcast if we
Yeah.
wanted to. There's just so many new ones, which is great. But standards are having an issue keeping up with these new technologies. There's a big risk factor for a cement producer, for a builder, for a developer, and there's a liability factor. So you need to come up with the right solution that's going to be de-risked, that's not going to pose a problem, and that you're going to see easy adoption, but also the scalability factor too. Over here, fly ash and slag are finite. They will run out. We can't satisfy the whole of the market, so that solution's really not the actual full solution. I think it's a very interesting time because of the rate of adoption of these new technologies, because of the customer-driven demand, because of the government requirements, because of the investments coming in, because of a lot of these different factors, even the industry itself looking to lower and get to net zero and lower their carbon footprint. So it's really exciting for us.
When do you think that the market will essentially cross the chasm into sort of mass market adoption and things will settle down?
Yeah, that's a great question. I think that's a crystal ball scenario. I would say from where we're looking and the interest that we have, everyone's either right now adopting or at least dipping their toe into the pool. When we get mass market adoption, is I think when a little more of the regulations come in, and then maybe there's more of a customer driven demand behind it. Because a lot of the customer driven demand that we're seeing from larger development companies, you're also looking at the big tech companies that now more than ever, because of AI and the increased carbon footprint per search or per use of that AI itself, creates a significant carbon footprint. And they're needing to do anything they can while they're building these data centers that create more carbon footprint. How can we lower that? So I think as we just continue to move on, it's going to get more customer driven demand. It's going to get more government regulations. It's going to also push the competitive landscape to say, okay, well, I need a sustainable solution to keep up with my competitor, or I need the edge against my competitor to also win these bids, get more business. And I think I'm seeing a lot of it now as like marketing. They're marketing the solution. Hey, I got this low carbon footprint concrete. It's a big marketing ploy. It's great. But I think this chasm crossing will occur maybe in the next couple of years, in the next 1 to 5 years. It's really challenging to say, but I have a sense that it's coming faster than we think.
And you spoke a second ago about the customer demand.
Mm-hmm.
What would you say are the key decision factors or the drivers for a large building materials company or a concrete company to decide between the different types of green concrete solutions out there?
I think sometimes what we're seeing is that it's dictated from these tech companies saying, hey, I want a reduction of this percent of carbon footprint. You can use whatever it is, but just make sure it meets these performance metrics or has a standard that it specifies underneath. So it's a little challenging because we're actually seeing that they're looking at really every type of solution they can find, and it always boils back down to cost. Can we charge a green premium? Can we provide enough of a benefit where we can charge that green premium, or can we find a way where there's no green premium, we can still make a profit and we can still do business and we can still maintain business or generate more business? So it's quite all over the place.
And I'm interested in your, I guess, your sort of your choice around routes to market, because you've sort of spoken quite extensively around your choice to go to market via concrete companies. What is your thought process behind that?
So initially, we actually went to said project owner, project developer, because they were the ones asking for us. But what ended up happening, so our first project was with the US Department of Transportation doing a roadway paving project, which was a great experience. And it was great to get out there, and it was great to our
That's an
first real
amazing
world
first
project.
client.
It's pretty good.
Yeah.
Yeah. And then our second client and project was with Google, another good one. But what we found out there, to your question, is that when we did this with Google, we're like, sure, we're going to make this material. We're going to go ahead and provide this material so you can make carbon capturing concrete for your built environment project that we're doing with you guys. But we ended up having to go back to the concrete company to find a way to integrate with them. So it was actually, we ended up having to backpedal. It made it more challenging because the concrete company didn't want to have anything to do with us. But then when Google's like, it's spec'd in there, you have to do it, and we're paying you, and just do it, it got done. But it just kind of made it a little more challenging. For us now, we look to partner with cement and concrete companies so we can actually get it into all marketplaces. That way, when a customer looks for it, we don't have to have the whole challenging routine of maybe working with a cement or concrete company, them giving us a hard time. Actually, they poured the concrete like 2 or 3 times before they added our material. Google made them dig all the concrete up 2 or 3 times before they put it back in there with our material. So it was funny, but it was a pain in the ass. And I guarantee you, the cement and concrete companies were not happy with us because they were like, you guys are a pain in the ass.
Yeah.
But it wasn't us. It was going
Yeah.
to Google first. And it was a great lesson for us to figure out, hey, how do we do business the best way? How can we benefit and have mutually beneficial relationships with the producers and with the end customers? And that's really what we were looking to find. We want everyone to win, including the environment. And that's really the bottom line there.
And I think your approach there around the science, the technical use case, but also the business element makes your journey building carbon limits so interesting, because it really is, without taking into account those business economic drivers, we really are missing a bit of a trick. I'm really interested for your perspective on tackling the green premium. The green premium is a big challenge faced
Yes.
by a lot of climate tech companies around the world. Really
Yeah.
interested in your experience and your learnings overcoming that. And
hmm
if you wouldn't mind also first, just for the benefit of the audience that aren't aware of it, just explain exactly what that green premium means.
Sure. So yeah, that's a really sensitive and really important area, certainly when we're looking for customer adoption. So the green premium is effectively take 1 cubic meter of concrete, let's say cost you 100 pounds versus 1 cubic meter of concrete with capture. Maybe it cost you 110 pounds. That green premium would be that increase in cost, kind of correlating it to buying a conventional piece of fruit to a organic piece of fruit. You always know you're going to pay a little bit more for that organic piece of fruit, but you don't want to. And in an industry, especially like the cement and concrete industry, where margins are very thin, profit margins are very thin, charging a green premium is not an easy pill to swallow unless you have a very good value proposition. And I say that meaning, are we increasing performance? Are we lowering the amount of cement? Are we doing something that adds another value, which either they can derive a savings from that value, like lowering the amount of cement because we've added a little bit of our product, or it's increasing the performance. It's making it stronger, last longer, needing less maintenance. But the other big piece boils into additionality. The additionality being when we're capturing CO2 into concrete with CaptureCrete with our partners, our project partners, our licensing partners, we can generate carbon credits. Those carbon credits can be shared from a revenue or from a carbon credit basis with those partners for project partners or licensing partners, which can make up for some of those costs to maybe mitigate a green premium or minimize a green premium. This way, that carbon credit can effectively gain more adoption and get more people on board because initially they don't want to pay a green premium unless you have something that you can really clearly state that they want and they need. That is a challenge.
How much of that green premium do the carbon credits chip into?
So that's a it depends answer. Not every piece of concrete is created equal. Let's say we have stucco that goes on the side of buildings. Here in Florida, stucco is put on the outside of a concrete block, and that has a higher ability to capture CO2 versus a concrete road that has less porosity for more CO2 to get in there. So the amount of carbon credits that could be generated from that change versus a precast lightweight concrete product, which they capture a lot more CO2 as well. So it really depends on that. And then it depends also on the size of the customer. If you have a small customer with specialty product, they're already charging a higher premium. So it's easier for them to tack a little bit more on because they also can gain more market share versus a large producer that is super price sensitive, that doesn't want to charge a green premium at all, that could lose business, that wants to gain as much of the market as they can, and it's volume, volume, volume. The carbon credits help a lot, but also it's on a case by case scenario with us. Every piece of concrete captures a different amount of CO2. Also, if we were to cast some and make some concrete products with CaptureCrete where you are versus where I am here in South Florida, the amount of CO2 to be captured in these different locations based on relative humidity, temperature, and the actual environment is different also. So there's a lot of different variabilities within it, but I think ultimately it tells a really great story. What's better than saying, hey, my house is actually capturing as much CO2 as 100 trees do in an entire year? Makes you feel good, makes us feel good, makes everyone kind of feel good. You're telling a great story, and then you can also capture some revenue on the back end.
Tim, you said at the start that you're not from the concrete industry and you found yourself in this industry because of the opportunity and the purpose around making a massive impact. Thinking about some of the other hard to abate sectors, maybe steel and others, what would you say have been your key learnings and what advice would you give to other founders and innovators tackling similar challenges in the other hard to abate sectors?
So, what I would say from our experience with helping decarbonize the concrete industry is absolutely when we're looking to create a value proposition, if we can have an economic incentive on the back end, that's critical. My recommendation and my advice to those that are working into other hard to abate industries where carbon capture is a thing and where there's methodologies around that carbon capture, I would highly recommend that they find a way to get those carbon credits verified and or validated and verified so they can offer that economic incentive as well. Another big reason why carbon credit validation and verification, which is done by a third-party carbon registry, which is an organization that ensures you're actually capturing the CO2 via another third party that's verifying it and that's testing and checking, is that you can quantifiably convey to those end users, customers, or partners what the actual carbon footprint savings and reduction is. And it tells a great story. It gives them another, a position or a better position in the marketplace. Above and beyond that, it's just clear value propositions, but it's clear value propositions that they actually want. You can certainly come up with your own, and if those value propositions don't align with the industry, then really not. It's something great to say or something good to put on a piece of marketing material, but above and beyond that, it's not going to do anyone any good.
Tim, thank you so much for your time. I really appreciate it. It's been absolutely fascinating.
It's been really great. Thanks, Jack.